Assalamu alaikum everyone, welcome back to Developer Maroof. In today's lesson, we'll learn about functional programming concepts, a style of coding that uses pure functions, higher order functions, compositions, and currying. So let's start coding. So our first concept is pure function. Let's add a comment. So a pure function always returns the same output for the same input and has no side effects. Let me show you. So first let's add another comment, pure, which is same input equals same output and has no side effects. So let me create a function first, which is an add function, and it has two parameters, a and b, and we will return a plus b. So this is our pure function. Let's see the results. Let's say log add 3 and 4. So its output will be 7 because 3 plus 4 will be 7. We are returning 7 here. And if I log it again, it will give the same output, 7, for the same input because it is the same input, 3 and 4 here. That's why we are getting the same output here. So this is called a pure function. No matter how many times we call add function with 3 and 4 arguments or values, we always get 7. That is a pure function because the value of this function is predictable. We can predict because its value will be obvious. We are adding two values. So no matter how many times we invoke this function with the same values, we will get the same results. Now let me show you an impure function so you can see the difference. Let's add a comment, impure, which is modifies external state. So let's create a variable count equals 0, and let's create a function. Let's name it increment. Inside that we can say count plus plus, and we will return our count. So this is an impure function. Its value is not predictable because we don't know how many times this increment function have called. So if we call it again, we don't know what value we get. So let's log it to understand better. Let's invoke this function increment, and we will see we are getting 1 because we have increment our 0 with 1. And now if we call it again, we will get the different result. We are getting 2 because 1 plus 1 is 2. So you see the same function call but different results each time. No matter how many times I call it, we will get different results. You see, so it depends on and changes an external variable, so it is impure. Let me show you a pure function with a no side effect version. Let me add a comment, pure, and let's say pure version with no side effects. Let's create a function, pure multiply, and it is multiplying a and b. Let's return a asterisk b, and if I log pure multiply, so we multiply 5 and 3, so its result is predictable. So 5 multiplied 3 will be 15. You see here we are getting 15. No matter how many times I call it, we will get the same result. It is a pure function. It is easy to test. That is why it is a pure function. So that's it for pure function and impure functions. Let's comment it out, and let me show you what are higher order functions. So let's add a comment, higher order functions. So basically a higher order function either takes a function as an argument or return a function. We have already used some like map and filter. Let me show you how to make your own. So let's create a function. Let's name it apply operation, and let's pass a, b, and any operation as a parameter. Inside that we will return operation from our parameter, which will be a function because we will pass a function in an argument. So that's why it is called a higher order function. So let's say inside that function we have a and b. So we will pass same parameter inside that function. So basically we pass a different function to the same higher order function, and it applies them. So let's add a log. Let's invoke that apply operation function, our higher order function, and inside that we can pass 10 as a value and 5 as b value, and any type of function. Let's put our same function which we have already created. Oh, let's uncomment these and use these right here. So I'm adding add function, which is this one, and copy this, and let's pass a different function here. Now we see in the result we are getting 15 first time because 10 goes here, 5 goes here, and add goes here. So this function will get the same logic what we have inside our add function. So add function gets a and b. A and b is 10 and 5. So it will add 10 and 5 and return us the value. So 10 plus 5 will be 15. So that's why we are getting 15 here. Same way, we are getting 50 here because we are multiplying 10 and 5 right here. So this is called a higher order function, which takes a function as an argument and return a function. Let me give you another example. Let's say return a function, and let's create a function. Create greeter, and let's pass our greeting here. Inside that we can return any function. Let's say function, and we have another parameter name here. Inside that we can just return our message. Let's say our greeting will be printed here, comma our name. Sorry. Now let's make a variable here, const say hello equals create greeter. Inside that we can pass our greeting here, hello, and let's create another variable, const say salam equals create another greeting salam or assalam alaikum. So now we have two different greetings. If I log this, let's say hello, because say hello variable is equals to this function which has hello greeting, and say salam is equals to different greeting. So now if we call say hello with any name, so whatever we put inside here will go to name. Let's say Maruf. And inside our second greeting, we will say Maruf. Now we see we are printing hello Maruf here for the first one, assalamu alaikum Maruf here for the second one. So we put here hello will go here, and then we call it or invoke it right here, and we pass Maruf. So Maruf will go inside this function, and we are returning greeting and our name and returning the message. So that's why we are getting those two with a different greeting. So what this function is doing, it is returning a new function. We saved those return function and call them separate. So I hope you get the concept of higher order function. Let's comment these out, and let's comment these out as well. Come here. So our third concept will be function composition. Let's add a comment. Function composition. So basically, function composition means combining small functions into a bigger one. We will build a simple pipe function that runs functions left to right. Let me give you an example. Let's create some variables. Let's say const double, which will be equal to a function. So let's say it has x value, and it will return x multiply 2. And same way we have 3 more variables. Let's say it will add a 10 to it, and it will return square of that number. So x multiply 10 and x multiply x. Now let's do first manual composition. So let's say manual composition, and let's add a log here, and let's invoke our add 10 function. And inside that we can invoke another function. Let's say invoke our double function. And inside that we can pass any value. Let's say 5, and the result is 100 because we invoke double, it is getting 5. So 5 multiply 2 will be 10. So 10 goes here, then it will run this function. So the 10 will go here, and 10 multiply 10 will be 100. So that's why we are getting 100 as a result. That's called a manual composition function inside a function as an argument. Now let me show you how pipe works. Let's add a comment pipe, and let's say it runs functions left to right. Now let's create a function. Let's name it pipe. Let's add a rest operator, and we have functions fns, let's say, and it is returning another function. So we will have a value of that function, and it will return each function dot reduce. We have already covered that reduce method. Basically this reduce method is for arrays. You can go and check it out of our previous lessons. So it will have an accumulator. Sorry, inside that it is a callback function, so another function here, and it will take an accumulator and a function. So function, we pass accumulator inside it, comma, let's get our value. So I created a pipe. Now let me store it inside variables. Let's say const transform equals pipe. Now let's pass those functions. So those functions will be these function which we have created right here. Let's pass those. Let's say double, comma, add 10, comma, square. And now if we log this transform, let's pass any value here. So whatever we pass here will go here, as we did right inside these higher order functions. So let's pass 3. So now, as I said, pipe runs functions left to right. So first it will get the result of this one, passing 3. Then whatever the value it gets from here, it will go here by taking its value as a parameter or an argument. Then it get the value this one to this, left to right, and final result will be given by this function. So if you First let's comment it out, and if we see here, we are getting 3600. Now if we see, we pass 3 here, so 3 will go here. Then as a reduce method, we have accumulator, then function, then this. So 3 will go inside this x. So 3 multiplied by 2 is equals to 6. So then 6 will go here, so 6 here, and 6 multiplied by 10, then whatever the result will be, it's a 60. So 60, then 60 will go here, and then 60 multiplied by 60 will be 3600. So that is our result. So basically pipe takes an array of functions and runs them one after another, passing each result to the next function. So that is the concept of function composition. Let's comment these out, and let me show you our final concept, which is currying. So let's add a comment, currying. So basically currying means converting a function that takes multiple arguments into a chain of functions that each take one argument. So let me show you some examples. So let's add a comment with normal function first. So this is our normal function, multiply. We have a and b. Inside this we will return a asterisk b. So this is our normal function. Let's create curried version of that function. Let's add a comment, curried version. Let's create a function, curried multiply a, and then we will return a function. We have b inside it, then we will return a multiply b. So this is a curried version of that function. Basically currying lets us create specialized function by fixing some argument. Let me add a log first. Let's add a log, curried multiply, then in the first parenthesis we will get 3, and the second parenthesis we will pass 4. You notice we are not doing what we have done here. You see, curried function is much cleaner than this method. So we are getting 12 here. So 3 will go here and b will come from here, then 3 multiplied by 4 will be 12. Now let me show you its partial application. Let me add a comment here, partial application, and what it is it will be used with fixed first argument. Let me show you practically. So let's create a variable called triple equals curried multiply, and inside that we can pass 3. And now if we log, let's say triple, then pass 5 and duplicate it and pass 10. Now if we see, we are getting 15 first, then we are getting 30. If you want to write it like this, you can do that as well. Now let me show you arrow currying, arrow function currying. So let's create a curried add equals, let's equal it with a function. Let's say a, then make it return a function with a plus b. Now let's create another variable, add 5 equals to that curried add function. Let's pass 5 first. 5 it will be given to a. Then if we log, add 5, then add 3 here. 3 will go to b. Then again we will pass 20 here. Now you see we are getting 8 and 25. So this is the same function but with different syntax or different versions of it with arrow and partial application. So triple always multiplies by 3, and add 5 will always multiply by 5. Not multiply but adds 5. So I hope you get the concept of currying as well. Let's comment it out. So that's it for today's lesson. You just learned about functional programming, pure functions, impure functions, higher order functions, compositions with pipe, and currying. In the next lesson we will learn about regular expression in JavaScript. If this helped you, like the video, subscribe, and share it with someone learning JavaScript. Jazakallahu khair for watching. Allah Hafiz.